This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 15 of graphing cosine functions, and on this video we're going to graph y equals the cosine of 3x over 2 minus 3 pi plus 1. So hopefully you see from the argument, in other words what's in parentheses here, is that we're going to have a different period, and there's also going to be a phase shift. There's also a vertical shift because this plus 1 at the end, but the amplitude's 1 because there's no coefficient except 1 in front of the cosine. Alright, so we have a lot going on here. Let's work on the period first. So remember that 3x over 2 is the same thing as 3 halves x, which means in this case b equals 3 halves. So to get the period, we take 2 pi, the normal period for cosine, and we divide by b. So we're going to divide by 3 halves, and dividing by fractions means you're multiplying by the reciprocal, so that is times 2/3, and that gives me 4 pi over 3. So our period is 4 pi over 3. So let's write that down. The period is 4 pi over 3. Now, when I find my phase shift, all right, I'll be able to get my first x-coordinate, and remember, to get the next x-coordinate, you're going to have to do a fourth of the period. So let's just figure out what a fourth of the period is. A fourth of 4 pi over 3 is going to just be pi over 3. Oh, that's nice. At least it's going to have a common denominator. So, actually, I don't know if it's going to have a common denominator yet. I spoke too soon. But I am going to add pi over 3 to whatever the phase shift is. So our next thing is to figure out the phase shift. So let's do that next. All right, so to figure out the phase shift, we want to take what's in the parentheses here, the argument, 3x over 2 minus 3 pi, and set it equal to 0 and solve for x. So let's see, we could add 3 pi to both sides first, which is 3x over 2 equals 3 pi. And now remember, this is 3 halves x, so I can multiply both sides by the reciprocal, which is 2/3, to solve for x. Now, there are other ways to solve, but this is the way I chose to do it. So the 2's and the 3's cancel. I'm going to get that x equals, now notice this is, I could cancel the 3's, right? And I'll get 2 pi. Okay? But that's the same thing as 6 pi over 3. And the reason I'm writing it that way is because notice over here, when I add a fourth of the period, I'm going to have to add pi over 3. So I actually might want to keep it as 6 pi over 3, so I have the same denominator as I have over here. Okay? But it's still really the number 2 pi, whether you write it as 6 pi over 3 or 2 pi. So this will be our first x-coordinate, right? Our key coordinate. How would we get the next one? Our next one, we would take that coordinate and add this pi over 3 to get the next one. And then you would add again to get the next one. So I hope you could see it's going to be 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, etc. So it won't be too difficult as long as we left that with a common denominator. But the phase shift is really just this number here. The phase shift is plus 2 pi. So I'm going to write that. The phase shift is actually 2 pi units, and since it's plus, to the right. Okay, so let's do our chart, right, our x and y chart, and then we'll get some more information here. So we've got our period of 4 pi over 3, our first x-coordinate will be 6 pi over 3, and then 7 pi over 3. All right, so we've got our period listed over here, our key coordinates are 6 pi over 3, 7 pi over 3. We just add another pi over 3 to get 8 pi over 3. Add pi over 3 again, we're at 9 pi over 3 and 10 pi over 3. Remember, there's always 5 key coordinates, and that is one complete cycle, one complete period. So just take a note here. 10 pi over 3 minus 6 pi over 3 is 4 pi over 3. Oops, and we're supposed to get 2 pi over 3. What happened? Oops, that's why. It's actually 4 pi over 3. That is what it says on the previous page. Just let's check it up. Yeah, the period was 4 pi over 3. Just copied it wrong. So there we are. We have 4 pi over 3, and that is the difference between 6 pi over 3 and 10 pi over 3. So I can see I have a full cycle here. So now we want to get the y values here, which is going to be the cosine of, well, what this means is if I put these values, like 6 pi over 3 in here for x, and I simplify inside this parentheses, I should end up with the cosine of 0, which over here will be 1. So we have this numbers from this chart over here, the y values, 1, 0, negative 1, 0, 1, right? And then I'm adding this one onto it. That is the vertical shift. So I've got 2, 1, 0, 1, 2. It's symmetric as usual. So when I'm going to graph this, I know I'm going in between 6 pi over 3 to 10 pi over 3, so I need to break everything up into thirds, right? Whatever the denominator is till I get to pi. And I got to go all the way to 10. So let's see. On my y coordinates, I'm going in between 0 and 2. So let's write this down, by the way. What's the domain? Always negative infinity to infinity. From our chart, we could see the y varies between 0 and 2. Let's see, the amplitude was 1, right, because that was the coefficient of cosine, just the absolute value. The vertical shift was up 1 unit. And the phase shift, I'm going to put PS for phase shift. Running out of room here. Let's see, what was the phase shift? Let's go back over here. So the phase shift, remember, was 2 pi units to the right. 2 pi to the right. All right, so now if you want to graph it, we're going in between 0 and 2. So I'm going to do my x-axis kind of low. And my y-axis way over here to the left. And I need to get at least a 10 pi over 3. So 1, 2, 3, there's 1 pi, right? 1, 2, 3, there's 2 pi. 1, 2, 3, there's 3 pi. Oops, that doesn't look like a pi. Looks like an H. Remember, that's 9 pi over 3, and here's my 10 pi over 3. Okay, so we're ready. We have 6 pi over 3, 2. Now, 6 pi over 3 is the same as 2 pi, right? So here's 2 pi, and I'm going up 2. Forgot to mark my y-axis. There we are. So we're going up, starting here. Then we're doing 7 pi over 3, 1. Okay, so this is 6 pi over 3. Here's 7 pi over 3. It's right here. Then we add 8 pi over 3 down to 0. 9 pi over 3 up to 1. And 10 pi over 3 back up at 2. And remember, this is not like a V. Some people like to draw some V shape. Make sure you curve it. And we could go over to the left and draw some more order pairs so it's easier to get the picture. But practice making it curvy and showing what happens at the end. It starts going down again. This is going up, and there we have it. Okay, that's a pretty tricky one. You might want to try doing this one all on your own 2 or 3 times to make sure you really have it down. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.